today and tomorrow. So so we're gonna come back to campus on Thursday and Friday. So basically, we're gonna meet each other 2 more days, and then the final exam. So today and tomorrow will be on Zoom, and then we should have received the chair email, the department chair regarding to the heat issue. So I do apologize for that things, and it's happening last semester as well. So I think that's pretty appropriate. But anyhow, we're gonna have the lecture on Zoom. I'm gonna post the recording on Blackboard very soon. So I want to create a certain file. So let's say we have the lecture videos, and so this one gonna be posted after class. So you have like a few minutes to step away from the screen, so you can actually, watch the YouTube video. So I'm gonna upload it on Blackboard. Take a while for some reason. Okay. All right. So I also gonna post the classroom. It should be under course assessment. So you need to I'm gonna recommend you a certain file. You can upload it. You can screenshot. You can take pictures, and then you're gonna upload it into the PDF file and submit it Blackboard. Okay, so make another file we call lecture notes. So basically, I'm gonna post all of the notes today and tomorrow under these two files. Okay. Okay, so we have lecture notes, lecture videos, so we don't actually need this. So let me just like we do have the course content, which is the chapter summary I posted. I actually post all of the class lectures for the rest of the semester ahead of the times, but it will be complicated if you study all of this because there will be some chapter that will not be covered, especially the trigonometry application. So we're definitely going to focus on the thing that will be on the final exam. And then I do not have any calculators, so but let me just double check that. I do have the VI83, but I'm not sure if that's still working. Yeah, it's still so which is an online calculator that I use every semester when I teach an online course. So this one is really handy. However, that having this calculator that's perfectly okay. I'm going to show you how to do the sine, cosine, and the tangent on the phone calculator if you need them. So this one is this is for the T83 plus, so it's different. Okay. So far so good. We're gonna cover chapter 5 today and chapter 6 tomorrow and chapter 7 for the next 2 days. Chapter 7 actually the most complicated chapter. We need to spend actually a little more time. I also planning out the practice final exam. However, it took me like a couple of days to get it done. So I finished like a couple of work, but I'm still working on it. So the file is not ready yet. But I would definitely gonna finish it and give it to you guys on Friday before the final exam. So I want to make sure that people have a certain thing to study. So we need to know define the domain of functions, so on and so forth. This is what we call the practice final exam, but it's not ready yet. I only prepare like 4 or 5 questions compared to the math department final exam. All right, so any questions before we started? Any questions, any concern? Okay, so make sure that we have we need to follow the rest of the schedule. So we have no class today. We have Tuesday and Thursday. We're going to cover basic trigonometry, and then trig identity, trig function, trig equation, and trig inverse. So we have a lot of topics to cover for the next 3 days. I'm sorry, for today, tomorrow, and the next day. And then the final exams, the final review going to be on Friday. So the next Monday, we have no class one more time. And then on Tuesday, going to be the final exam. So let's get started with a certain thing we call trigonometry, basic trigonometry. So this is the topic that we work through it. Okay. So we literally understand that the unit circle is basically according to 2 pi, right? For 360 degree. We have learned it, and we're definitely going to see them one more time. So let me just go back to the course content and open the chapter 5, which is called a basic trigonometry function. We're gonna skip some of the step, but basically what we need to know is we're gonna measure the degree like this. Okay. Okay, so a circle gonna divide it by divided into 4 different quadrants. So we need to understand that it was the first quadrant is literally going to be on this, right? So this is the first one, correct? And then the second quadrant, and then the third, and then the fourth. So if you don't understand those Greek numbers, so I'm going to put it down. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So each quadrant is going to occupy 90 degrees. Okay, so how can we measure the angle? So the angle should be measured from this point, starting on the right axis right here. So we're going to start it from 0 and 1s right there. Okay, so this is 0 and 1, so on and so forth, right? So this is what we call the initial site. Okay, so this is what we call the initial site. Okay, and then so let's say we're gonna branch out to this angle. Okay, so this is what we call the terminal site. So the angle must be measured counterclockwise. So we're gonna start from the initial site, and then you go all the way. We go all the way down. Okay, so this is how we're gonna measure the angle right here in trigonometry. Okay, so let me just repeat that again. So the initial site always started from here. So this is what we call the initial site, right? And then after that, we're gonna measure the angle right here. Okay, so this is what we have for a certain angle, and then it's basically more than 180 degree, but I'm not sure like how much angle that we're going to have, but apparently that this is what we got from the pictures. Okay, so in other words, we can have this, right? And then we look at that. This is what we call initial. Okay, and then we're gonna head it to the bottom. And this is what we have for the angle. Okay. So apparently that it's not quite easy to look at it. You might look at the angle on the other side, which is right here, but this is actually not what we're looking for. So this is what we have for the angle. So a lot of us might call the angle as alpha, gamma, beta, or certain things like theta, something like this. So I call x, angle x, okay? But for some reason, if you don't want to look at the angles for different names, that's perfectly fine, because I don't want to mess up with the x and y coordinates. Okay, so I would like to call the angle at a very specific name, so which is called theta. Okay, we call angle theta. So the theta is literally not my word. The theta, you can take a look at it. The theta is actually symbols. Okay, it's actually a mathematical symbol, and it's go like this. And then The data commonly used indicated at an angle, and then you can literally see what the explanations on GoGo. And we're not going to look at the astronomy perspective, and then it's just the data, and then it can be measured after we call a so-called odd lamp, or we're going to finish it. Okay, so we're going to skip that part. So we call data to represent the angle, but I might change later on after we finish this part. I just call an angle as x, just for our own convenience. So this is what we call an angle. So the angle will be measured counterclockwise, correct? Counterclockwise. So I have to go to the counterclockwise direction. So basically, this is what we have. Okay, so we do have like a certain things what we call the reference angle. So let's say the reference angle is sort of like making sure that we're gonna bring the angle into something like between 90 degrees. Okay, so the reference angles. We definitely not gonna spend times working on it. Would be an angle that that is between 0 and 90 degree. Okay. So the reference angle most likely hold the same characteristic of any angles, except for the fact that you might have some negative side and so on and so forth. So let's say we have like a 225 degree, and then if I want to bring back to the reference angle, so you might need to add or subtract 180 degrees, right? So we need to add or subtract, okay, 180 degrees every single time. So we also learned the fact that like 180 degree is literally pi. So I might have some trouble drawing some pi pictures using this syntax, using this software, but I think it's perfectly fine that you guys can see what it is. So the pi, again, that it's basically the half circumference of a unit circle. So the pi was like when you have a radius equal to 1, is occupy 1/2 of the circle. So we just call 180 degree. So in other words, that if we have 225, then you just subtract 180, and it's going to hold pretty much the same characteristics at 180. So we can use it on a calculator. So we can take 225 minus 180, and then we can just simply say the reference angle for 225 is 45 degrees. Okay, so it's so much for that. So you can have like 450, 480, and then we can subtract 180 every single times. So we can figure that out, the reference angles by the calculations. So in this case, so we can have, but you have to make sure that the angle will be bounded between 0 to 90 degrees. So we take 480 minus 180. So that number is still really big. And then we keep going to subtract. Okay, so 300 and minus 180. So we can see how it looks like. So that is 120. And then I believe it's 120. And now if you ask me like how we're gonna get it done, so we're gonna take 120 minus 180, and then you gotta take absolute value after this. Okay, so that would be negative 60 degree. So we can do the math on a calculator. So negative 60. So we're gonna take the absolute value, right? Take the absolute value. So this one, absolute value. So the absolute value meaning that you're gonna transform it into positive value. So this one is 60 degrees for the reference angle. I don't have enough space here, but anyhow, so that'd be 60. All right, and it's just not a big deal, but the reference angle should be better between 0 and 90 degrees, so you gotta be careful for that. So each time that you subtract it by 180 or add 180, so you might have to be careful, okay? Or you might have to take the absolute value for that, and so on and so forth. But the reference angles is literally important because if you want to take a sine, cosine for certain things, and then if the angle is getting really big, the reference angle is really helpful. Okay. But soon we have a calculator, so it doesn't matter what it is. And then we have learned about the how we're gonna convert it from radian to degree and from degree to radian. So basically, all we need to do just let's say we have 15 degrees, so we go into multiply by pi over 180. So that essentially going to give you pi over 12. So converting from degree to radian is actually much harder because we need to simplify them, right? So let's say 45 degrees, and then you might have to convert it and then make it equal to pi over 4, and so on and so forth. So I believe it's so important for some of the angle that you see right there. And then I would like you people to keep in mind for a certain degree. So let's say 45 degree is pi over 4. Okay. I'm gonna just copy that part. Okay. So again, that how we're gonna change it was simply just taking um, 45 degree, we multiply by pi over 180, and then cost them out. And this is 104, and then so that will be pi over 4. Okay. And another thing is that we have 60 degree, and essentially gonna be the same when we convert it to uh, radian. So we simply would take 60 times pi over 180. So we crossed out 60 and 180. So we have pi over 3. So 1 and 3, right? I just want to give you a certain reminder because this is what we have done from last class. So I don't want people just understand that this is so hard and then, but it's simply we just need to multiply by pi over 180. Right? So a lot of if some of you who have trouble converting from degree to radian, so make sure that why not the opposite? Why not the other way around? Like why not multiply by 180 over pi? Because remember they must stay the same unit on the top and the bottom in order to cancel out. Right? If you multiply by 180 over pi cannot be canceled out with a degree. So the 180 have to be in the bottom, so we can cost them out right that. And then we have 2 over 3, we divide both sides by 60. So 2 pi over 3 basically tells us that, well, this is what we got here. And then if you want to know what this 2 pi over 3 looks like, I'm going to give you the unit circle. Okay. It looks really confusing, but let me just give it to you guys right here. And this is what we have for the chart. The chart was too big, so which is not really appropriate. So let me just make it a little smaller. So ignore all the numbers that we have. So 2 pi over 3 is simply this angle. I'll show you what it is. Okay, so this is 2 pi over 3, right? So this is 0, right? And then R. It looks very confusing, I understand, but you don't necessarily have to memorize all of this. So we can use a calculator to figure that out, okay? So for each part of it, it's just divided by pi over 12, which is upside pi over 12 in this case. And then we just keep doing that. So um, this is 2 pi over 3, actually. This is 180 degree, and then this is 2 pi over 3. Okay. So the 2 pi over 3 is simply the arc length that is going from the initial up to this point. So if you ask me what it means by 2 pi over 3, we just measure the arc length right here. It's mean the same. So instead of using the degree, so now we're using the arc length, the length of a circle. So this is 2 pi over 3. Okay. Okay. Does it make sense? Okay. So a lot of you might confuse, like, do they mean the same in terms of degree or radians? The answer is no. The degree we measure like the angle. The radian we measure the arc length. So let me just repeat that again, right? So degree we measure my angle. Okay. And then radian. So I'm using the different markers. So we measure by the arc length of a circle. Okay. So it's not going to be the same, but technically we can treat them to be the same thing when we talk about the sine cosine. So let's say 120 degrees, so that would be 2 pi over 3. 45 degree is literally pi over 4. So 45 is right here. Okay, 45 is right here. So this is 45. Okay. So this is 45 degree. Okay. So I just want to make sure that it started from the very initial side. The initial side will not be changed. That will be starting from the horizontal axis, starting from the origins here. And then, so this is what we have for the initial side. Every angle have to start from here. Okay. All right. So now the next questions will be like, how much do we understand sine, cosine? How much do we know it, right, without value? Okay, so let me just use a very basic circle. I mean, they do have a pretty good chart, so we can literally check that they measure 360 degree using the ruler right there, and then they can also convert them into radian if you want to, but it doesn't matter. So now let me just use this unit circle to describe the sine, cosine. That will be our next topics. So a lot of us might be confused, like what it means by unit circle and why it's so important, because unit circle actually simplify the logic of sine, cosine, and tangent syntax. So this is what we call a unit circle. Okay. So basically what we need to do, again, that we're gonna have x and y axis. So I did not really sketch it properly, but it is what it looks like. Okay, so the x-axis we call the cosine. Okay, cosine. And then the y-axis that we call the sine. Okay. So remember, the unit circle, they're gonna have the values. So the values starting from 0, and then it's go to 1 on the left, correct? And then on the right, it's going to be negative, because this is on the right. I'm sorry, on the left value is -1, the right value is 1. The same thing on top of that. For the y value will be the sine, and then is will be 1, on the bottom is -1. So we basically need to understand some of that. So now people are very familiar with the angle, so we call the angle as angle T instead of call theta because it might be really hard for me on angle T. So it can be measured by the initial and the last one, the terminal sign. So this is what we call the angle T. Okay. So now the questions will be like, how can we measure the sine, cosine? What does that mean? So we're going to do that, right? So we're gonna draw a small line right there on the bottom, right? Okay. So let me use a different marker. Just want to make sure that it looks nice. Okay. So anything that we can vertically, the vertically gonna be the size of t. The psi will be the y-axis. The cosine is gonna be the x-axis. So in this case, so this is what we call the size of t. Okay. So the size of t have to be a certain value that we just don't know what that value is, but we need to determine what it is on a calculator. Okay. And the x values, on the other hand, I'm changing the marker a little bit. So this is the x value have to be lying on the x-axis, right? The y value should be on the vertical line axis. The x value should be on the horizontal line axis, right? So this is what we call for x. Are we good? Are we good with that, people? So the angle I changed from theta to t because I know some of you might be like, where's my theta going? So we're gonna use the t instead of theta. I don't like t. I'm sorry, I don't like theta to write on the screen, so I just changed that to t. Just want to make sure that people, just want to make sure I can write it properly on the screen. Okay, are we good? So the cosine is gonna be on the x-axis, right? On the horizontal axis, x. Okay. The sine, the sine will be on the vertical axis, right? On the vertical axis. Y. Okay. Are we good? All right. So apparently, sine, cosine. Remember, sine is going to be um, sine is going to be the y is corresponding to the y value. So we can see that at the angle t, both sine and cosine is positive, right? So we can see that the cosine is here. So this one should be positive values. The side line cannot be negative. It should be less than 1, right? But we just don't know what it is for the angle here. Okay, so we need to magnify it, okay, on the pictures, because remember, it's already sketched out in terms of some special angle, but we can literally gonna use a calculator to figure it out, okay? They actually have a chart for that as well, so this is what they give us, but I would definitely gonna give you the chart later on, but since I need to put that down, so we need to copy this chart on the final exam as well, because you don't want to spend time like measuring all of this values, okay? So let's say 30 degree, 45 degrees that represent to pi over 4, pi over 3, 60 degree, pi over 2 is 90 degrees, 2 pi over 3, we just did it, 120, 3 pi over 4, 5 pi over 6, and this is pi, right, and 180 degrees. So literally we go into interested to analyze one of them. The rest of that we can do the calculator to evaluate it. So because we do not have time, so let's say we talk about the angle that the t equal to 30 degrees. So that's gonna be the things we want to analyze a little bit. So remember, I do not have time to prove all of this, but it should be the same. Okay, so I just want to show you one of them, right? And then the t was simply what we have. So we're just using a magnify a little bit. So the t will be 30 degrees. So it should be the same from the picture that I saw that it has. So this is 30. Okay. Okay, it should be 30. And then this is what we have for the side length. So again, a lot of us, like, let's say, what is the size of 30 degree? Well, we use a calculator, we get it done. I understand it, I appreciate it, but we somehow want to know like where the 30 degree coming from. So this is what we have for the angle equal to 30. So this is 30 degree. Okay. All right. So the next thing that we need to know is that the unit circle, we're going to have the radius is equal to 1. So what does that mean by the radius equal to 1? So it's always be 1 for any side that you see here. So let's say this is 1, this is 1, so everything have to be 1. Okay, the radius. Okay. So now we need to figure out, like, this is what we have for the cosine of 30 degrees, right? The t equal to 30. And this is the size of 30 degrees. So we call this is x, and this is y. Okay, so just want to call them as x and y values. And then now we need to measure those two, right? Apparently that we can also branch out the angle on the other side. So that's gonna make the equilateral triangle, they're gonna have the same sides. Right? So basically what does that mean? No, I do not have a good picture for it. What does that mean is that this side length gonna be 1 as well, and this side length gonna be 1. Okay? So if this one is 1, so the y have to be equal to 1/2, right? Equal to 1/2, because this is 1/2 of this, correct? So the x, we can also use the Pythagorean theorem, I'm sorry. So to figure it out, we have a squared plus b squared, Pythagorean theorem. So it's going to give you like a squared plus b squared equal to c squared. We're definitely going to use that on the test. Okay, so we forget it. So we can have this is x squared plus y squared equal to 1. So we can figure that out. Okay, so why is that? Because we have a right triangle with 90 degrees here. So that's essentially going to give us, so we need to solve for x. X is not known. The y equal to 1/2 because this is 1/2 of the side line equal to 1. So we have a squared plus b squared equal to c squared. So the a was x, the b was y, and c equal to 1. So we can plug that in to see what that is. Okay, so we're solving for x. So we have x squared plus, so y squared equal to 1/2 square equal to 1 square is 1, right? So this is what we have. So now we just simply do 1/2 square. So we have is 1/4 square, and this no 1/2 square, and then square is 0.25, right? So we're gonna get x squared plus 0.25, which is a quarter. So I think this calculator is not good. And then we solving for x, so we subtract 1 for both sides, and then literally that's going to give you 3 over 4, so you can have x squared equal to 3 over 4. And then going to take the square root for this. So remember that the side length is positive. So basically what we're going to have, we need to write them in terms of the square root of 3 over the square root of 4, but you know the fact that the square root of 4 equal to 2. So the final answer should be radical 3 over 2. Over 2. So technically, what does that mean? When t equal to 30, so we can know the fact that the cosine will be x, will be radical 3 over 2, and then the y's, literally the sides, literally equal to 1/2. So at this point, I'm gonna write the value, the x and y value. So the x that's correspond to the cosines. Okay, let me just repeat that down. X that corresponds to the cosine that we have, which is evaluated. X will be radical 3 over 2. Okay. Over 2. I have such a hard time to draw. I taught the courses in a online, but it's harder for me to write them down. And then the y is 1 over 2. Okay, and then so this is 1/2. Okay, so this is what it looks like. Are we good? So this is what we have for 1 point, and then you're gonna figure it out for the other point. So let me just repeat that again. The x will represent cosine, so that'll be radical 3 over 2, and this is the x index, and this is the y index. Okay. Oh, okay. So that's a good question because this is a lateral triangle, so they have the same side length. So the whole side length here equal to 1, right? The whole side length here equal to 1. So this is 1, this is 1, and this is 1. Because this is 60 degree, this is 60 degree, and this is also 60 degree. Okay, so this is 60, this is 30, this is not a 30, this is 60. So they have the same angle, meaning that they must have the same side length as well. So if the whole side length equal to 1, and y is going to get 1/2, because this is only half, they must have the same distance, they will have the same side length as well. The distance must be the same, correct? So meaning that this is have to be half, and then by the triangle theorem, by the right triangle theorem, so we can literally have x squared plus y squared equal to 1 squared, and then we can solve for that, and this is going to give you x equal to radical 3 over 2. Okay, so the hardest part is like, how can I get y equal to 1/2? This is not magic, because I literally just going to draw the exact same angle, but on the bottom. And then I using a same theorem to figure it out. Okay, so remember when t equal to 30 degree is going to be the same as the t equal to pi over 6. So just want to let you know that we need to understand how to convert from radian and degree. So when you do it on the calculator, we're not going to make any mistakes on it. So we gotta be careful when you set up your calculator in terms of radians or degree when you do it on a final exam. So that's important. But if you can bring a chart, so you don't need the calculator. So for instance, let's say I want to figure out the size of 30 degree, and then that's gonna give me something, because remember, this is not in terms of degree. So we have to set up the mode right here. You're gonna go all the way to the bottom. So you're gonna press the degree. So now we do it one more time, size of 30. So we're gonna get 1/2, which is 0.5. Okay, so on the other hand, if we use the calculator to figure out what is the cosine of 30 degrees, so we're going to go to cosine of 30 degrees. So that's going to give you 0.866. And then if you ask me, what is 0.866? So the radical 3 over 2 will be exactly 0.866 on the calculator. So we can try it. Okay, so this is radical 3 over 2. And then when you put it on a calculator, and then you can take radical 3, and then we divide it by 2. So that is 0.866. Right? So this must be correct for the index. So let me just repeat that again. The x-index represents the cosine, the y-index represents the sine. And then if you want to take the cosine of 30 degrees, so we definitely have to use a calculator that it takes you the cosine of 30 degrees, so that'll be 0.866, but you don't exactly know that this will be equivalent to radical 3 over 2. So that's important to have the notes and see what it is for the entire unit circle. The same thing for y-index, so we can take the size of 30 degrees, so we can have 0.5, which is 1/2. Are we good? Okay. Also, if you prefer using radians, so we have to change the mode back to radian, and then we can try to figure it out. So, but you can't literally take the size of 30 degrees because that's going to give you some weird number. It's not equal to 0.5. In fact, that we need to take the side, and then we hit the pi. So the pi on the calculator will be second, and then hit a little format here, and then we divide it by 6. So when you close parentheses, so you're going to get 0.5. Okay, so it's different mode. So using the degree, so that'd be 30 degrees, using the radian, so the pi over 6. The same thing for the cosine, so we can have to press second, and then going to the pi over 6, so we're going to get 0.866, which is pretty much just the same thing that we got from radical 3 over 2. So understanding the index is very important. And then for the unit circle, we definitely need the list right there to understand what it is. But some people might say the unit circle might not be really helpful if you don't have this part. So I will show you why some of you might be like, why do we have so many index? How can we actually figure it out which index gonna be on which circle? All right, so this is not an easy task. Okay, hold on a second. So let me just using the tricks, right? The trick for trigonometry. The trick for trick. Okay. Literally, it's not something that really complicated, but we need to understand there are 4 different quadrants, right? And then we going to take this into account, okay, later on. So if you ask me what is the tangent, so the tangent is the t. Tangents will be y over x. Okay, the tangent is going to be y over x. So there are actually a few more indexes that we need to understand, and then we also rewrite this in terms of the tangent in terms of the sine over x will be the cosine. Okay, over cosine. I know this might not be easy to digest, and what does that mean by the tangent? What the use of it, right? But we haven't touched the finger on the application on it. I don't think that we have the time to do so, but it's really important that we measure a certain side length given by an angle, or vice versa. So let's say I have a certain side length. How can we measure the angle? So the trigonometry become very, very handy. So this is why they came up with different perspective for the tangent, for the secant, for the cosecant, and so on and so forth. So I know that it might not be easy, but the cotangent is just literally x over y will be the inverse of tan. Okay, so that would be x over y. So you can think of it, the cotangents would be cosine over sine, which is x over y. Okay, so this is the inverse of the tangent. Just want to make sure that we have it done. So this is x over y. And then we also have like the secant of t. The secant will be, I can use x. It makes no sense because I can use the angle as x. We use t. Okay. The secant is literally the inverse of the cosine, which is the inverse of x. So that is 1 over x. Okay. And then we also have like a CSC, which is called a cosecant, but it's literally not very important. But this is the inverse of size. But you're not going to memorize too much. You just need to understand the sine and then the secant. I feel like, I'm sorry, the sine, cosine, the tangent, and secant. The cotangents, we have to memorize it. I mean, we need to understand it as the inverse of tan, and then the opposite is just the way it is, right? For the cosecant, so this is what you need to worry about. Other than that, everything should be perfect. All right, so any questions so far? Yeah. What is the side? The side is literally the side is the y. The side will be the vertical axis. The y, the x is going to be cosine. The cosine will be the horizontal axis. Okay. It's really hard to understand it that way for the unit circle, but the side basically represents the y-index. Okay. Represent the y-index on the unit circle. Okay. Okay. You think of it that way so you don't really make any mistakes on it. And then for the cosine is represent the x-index on the unit circle. Okay. Yeah. The side will be here. The side is literally right there. The side, the vertical axis is actually, oh, you can't do it that way. You can do it the other way around. So this is what we have for the y value. So this is what we have for y here. If you don't mind, if we draw another picture for it, and then this is what we have for y. Okay. Right. This is what we have for y. Yeah, this is the y. This is the sine. This is the x. The same. Okay. So the side just represent the vertical axis of that angle after we take this. The radius is always be the longest side length between sine and cosine. So basically, sine and cosine cannot be more than 1. You can look it up on the pictures. For the right triangle, that the longest side length will be the opposite of the right angle. So the radius always be the longest side. So the sine and cosine should be less than 1. Yeah. I'm not gonna do another example how we're going to get those values, but we should understand that the size of 30 degree would be 1/2 because that represents the y-index. Okay, so we need to understand that the size of 30 degrees will be equal to 1/2, and then the cosine of 30 degrees will be radical 3/2. Okay, does it make sense a little bit here? And then I'm definitely going to show you like how we're going to compute all of this on a calculator. So let's say the cosecant equal to 1/y. But we're not going to talk about that actually. Cosecant is not so important. So all of these, we just need to understand the tan will be the y over x or the sine over cosine. But I feel like understand this one is better because it's going to be on the final exam. The other things are not very important. And the secant is a 1/cosine just to be fair. So we don't really get like really crazy stuff. So this is 1/cosine. Okay, so we're not gonna get like a lot of headaches on it. So we're gonna come back with this picture later on. So now we're gonna analyze it for the unit circle. Some of you will be very confusing, be like, what the heck was going on for this? And then you want to literally make sure that we understand every single piece of the index. So I might not have enough space, so I need to copy this total pictures, and then I might have to magnify a little bit. Okay. Okay. So this is what we have for the whole unit circle. I hope that it doesn't look so awful, right? So this is what we have for the unit circle values. For all angles, all special angles. Okay. So why do we call it a special angle? Because this value are literally written down in terms of the value that we can easily find, like 1/2, 3/4, something like this. So nobody going to ask you to figure out what is the size of 1 degree. So when you do the size of 1 degree, just want to make sure that I shift the mode back to degree. Okay, so nobody going to ask you what the size of 1 degree, so it's going to close to 0 because we can see that the y value is literally going to be 0 on the axis. Okay, so now given by the picture right there, you can think of it. So for 30 degree, so we can literally see that for the x-index, the x equal to radical 3/2, right? Will be the cosine of 30 degree. And then what does that mean? So this one equal to what, people? Everybody can see that? This one equal to radical 3/2, correct? Are we good? Yeah. The x-index is cosine of 30 degree, and that would be radical 3/2. A lot of you might be asking me, can I use the same thing for cosine of pi/6? Well, it's going to be the same. So we can use degree and radians interchangeably. So in this case, so if you do pi/6, so it's going to use the same result, which is radical 3/2. But you have to switch your calculator into the radian mode before we can figure it out. So that's going to be equal to radical 3/2. Okay, so this one is going to be the same. So I'm not going to rewrite them because radical term is making me hard to write, to draw on the pictures. I wish to have a class on campus so I don't have to draw all of this, but this is what it is, right? And then, so for the y value, so we can literally check the y is represent the y index on the second value. So that would be the size of 30 degrees, right? And then this is 1/2. If you want to draw out with some radians, so it's going to be the same thing. So 30 degree represent pi over 6. So this one is pi over 6. And then we also get the same thing, which is 1/2, right? I just show you guys on calculators and how you're going to get it done. Okay. Pi over 6. We're going to come back to the trick for trigonometry, and then I will tell you what it is. Okay, for each quadrant. So now we're going to go back to the second index. So the same thing for that. So let's say we have this 45. So I'm not going to sketch like 45-degree. So we're not going to prove it because it's going to take so long for the lecture. So what I have to do, which is going to make sure that this is in the degree mode. So the x index represent the cosine. So the cosine of 45-degree equal to 0.707. So a lot of you might be thinking, what is the 0.707? Does that have something to do with the radical 2 over 2? The answer is yes. So we need to understand that radical 2 over 2 will be equal to 0.707, right? So we gotta be careful. When you look at the graph and you look at the unit circle, be like, what is that thing? I don't get the same result on my calculator. The calculator shows cosine of 45-degree, cosine represent the x-index, will be 0.707. On the other hand, the result I got from the unit circle is radical 2 over 2. I'm not sure if that is correct, so we have to check it. We have to check that, right? So we're going to take radical 2, and then we divide it by 2. So what do we get? We're going to get exactly the same thing, which is 0.707, 106, something like that. We don't really care much about this. But we do understand that the cosine of 45-degree, that's going to give us radical 2 over 2, right? And so on and so forth. Are we good? Does it make sense? So we're not going to prove it. We're not going to prove like, what is the cosine of 45-degree and how people actually got to the final answers, but we don't have time. So it's simply just give you the answers on the calculator. I mean, we can just draw a right angle, right? We just draw a right triangle, and then you're gonna make another one, and so on and so forth, and then they must have the same side line, so on and so forth, and then figure it out. X and Y should be the same, and then we're gonna use the right triangle theorem to solve it. But again, that we do not have time for it, so I simply just stick with the answers on the unit circle, and then the answers that we can find on the calculator. The Y, the same thing, that we're gonna go for sine of 45-degree. So apparently that is going to give us radical 2 over 2. Okay. All right. So far so good. And then a lot of you might be asking like, hey, what is this one? And then it looks confusing to me, right? So we can literally check. This is 0 degree, and then the radian is going to be 0 or 2 pi. So the x-index is 1, so we can look at the cosine of 0 degree. So we know that it's going to be the terminal side going to be the same at the initial side. And then that's going to give you exactly the x values, right? So the cosine of 0 degree is literally 1. So you can basically use a calculator to figure it out if you want to, but it makes sense that we only have the x value without the y values. So the cosine of 0 degree is 1, right? And then on the other hand, the size of 0 is literally, we can do that on a calculator. The size of 0 is also 0, right? So this is what we have for the index 1 and 0. Okay, does it make sense? And then if you want to analyze the same thing for that part, So 3 pi over 4 or 5 pi over 6. So we're going to do the same thing. So, but remember, on the first quadrant, both x and y's are positive, correct? On this quadrant, so we can think of it on the first quadrant. On the first quadrant, both x and y's are positive, correct? Because you can't literally give me the negative values on this quadrant, right? Because all x and y are positive. Are we good? So both sine and cosine are positive. Are we good with this, people?
Yes.
Yeah. So how can you find a negative? Because both are positive on the right. But if you go to the second quadrant, right? If you go to the second quadrant, it's different. So the first quadrant's both x and y positive. Both sine, cosine positive. Because x and y is positive, so it's greater than 0, right? Okay. On the second quadrant, so we're going to look at that quadrant. All right. So on the second quadrant, what happened? Can you tell me which one is be positive, which one will be negative? So remember, psi is the y, the cosine will be the x. X will be negative. Apparently, x will be negative, so we can check all the x index are negative, right? I feel like that makes sense. Y be positive because y is still on top. I need to erase this, right? So for the second quadrant, I need to rewrite this first. So x will be x will be negative, meaning cosine will be negative, and then the sine will be positive, right? Sine will be positive because sine is y. Just want to make sure that we understand it. The cosine will be this. And so on and so forth, right? And then for the third quadrant, and then we understand that for the third quadrant, both x and y's are positive, right? Both sine and cosine are negative. I'm sorry, cosine negative. And then for the last quadrant, we can literally check that for the last quadrant, this is what we have for quadrant number 4. We do have x positive, but y will be negative. So in this case, for quadrant number 4, x will be positive, meaning cosine is positive, right? And then sine will be negative. So a lot of you might ask me, why I just only write sine and then not with the t? Well, I mean, it's implying the t, the angle, right? So we cannot just tell me that, well, this is just a sine cosine. What kind of angle is that? So depending on what it is. So we can literally check for the quadrant number 4 that both the quadrant 4 x will be positive and y will be negative, so and so on and so forth. Are we good? So if you want to check this index, so a lot of you might be thinking like they do use the same result, right? So let's say for 45 degree, for pi over 4 and 3 pi over 4, what does that mean? They seem to have the same values, which is radical 2 over 2. And then this one also negative radical 2 over 2. So the only thing that makes them different is that either it's going to be positive on the negative side. Correct? Are we good? Everybody sees that? So the same thing for So we analyze it, the different degree and different angle. I mean, different angle of the unit circle, right? Analyze the angles of each quadrant, right? So we think of it that they seem to have the same. They seem to have the same value of some specific angle, right? We just literally have different things. They seem to have the same value of some specific angle, except except negative positive, but different sign, right? Either negative positive. Okay. I think I feel like that's really important to understand it that way. So if you ask me how we're gonna take um, the cosine of 135, so I literally going to use the calculators, right? So I take this, so make sure that the mode was degree. So if cosine of 135 degrees, so it's going to give me negative radical 2/2. Okay, and then the same thing if we want to take the sine of 150 degree, and then I get 0.5, which is the same thing, and we're taking the sine of 30 degrees. So a lot of you might be like, well, they seem to have the same result, but it's except for like negative, we have to play around with some negative and with some positive value. But we need to make sure that the cosine of pi by 2, which is 90 degree, so which is that one, the cosine going to be 0. So you can see it, the x value is 0 because we don't have the value for x. So the sine of 90 degree in this case will be equal to 1. Right? So these values can be checked on the calculators, and then it's important to know what it is. So a lot of tricks here. The trick is for the trigonometry is so important, and then we can also figure out the tangent of a certain degree by taking the sine of a cosine, and then you figure it out using a table. So we do have a table for this. We do have a table for that, right? And then this is what we have for the table in this case. But trigonometry without using calculator, but I don't think that important because we can use the calculator to check them out, but just for some, just for your own convenience, that we understand that 0.707 is radical 2/2, radical 3/2 is 0.866, right? So I believe that's so important to understand to know that this is 0.866 in the calculator. And this one is 0.707 on the calculator. Okay. All right. So the tangent is just simply we're taking the y over x, and then we can figure it out. So let's say I want to figure out what is the tan of 30 degree. So the tan of 30 degrees, so when you use the calculator, is 0.577. So this is actually the angle, right? 0.577. Okay. And then we can also do like, we also know the fact that the tangent of t equal to y over x. So we can also take the sine of 30 degree over the cosine of 30 degree. So that's also essentially going to give us tan of 30 degrees as well. Will be sine of 30 over cosine of 30 degree. Okay. So the sine of 30 degree that we have is 1 over 2. And then the cosine of 30 degree is radical 3 over 2. So we can do that, and then so 1 over 2 over radical 3 over 2. So we should get, no, it's actually not the same thing. Yeah, I understand. So 1 over 2 is 0.5. So let me just do that. 1 over 2 divided by radical 3 over 2. Okay. It should be 0.577, so which is radical 3 over 3. Okay. Yeah. And all of this, we're gonna contribute on the unit circle, and then you can figure it out on a calculator. You can use a chart. Okay, so we also have a tangent, the sine, a cosine, and all of this. And then we're definitely gonna use this to solve some trigonometry problems. So this is gonna be in the final exam. So I really want to make sure that people know how to deal with this. So we might have a certain problem. So let me just try it out with different problems and see what it is, right? So let's say we had a problem here. We want to figure out the added trigonometry functions, or you might want to figure it out with sine and a tangent. Okay, so given by a certain value of x. So let me just elaborate on this process. This is a question that we see on a test. Okay. So the question will be like, let's t equal to 12 over 13 on quadrant number 4, and then we want to find the outer trigonometry function. So they just only give you the values, and then we need to figure out that angles, and then you don't exactly know what that angle is, right? But we can figure it out using the inverse angle. We're gonna learn it hopefully today. So we want to figure out the outer trigonometry function. So what does that mean? Let me just pull up the things here. So this is what we need to do. No. Okay. So this is an important question. Okay, so what does that mean by this? So I have like the cosine, which is 12 over 13. So this is what we have for x. We have the x index. Okay. We want to figure out the other indexes as well, which is including the tangent, including the cotangent, the secant, and so on and so forth. Okay. So the thing is that the cosine will be 12 or 13. And then I want to figure out the y. So it might not be easy using this thing. So this is where we're gonna go to the trigonometry, the trick for trigonometry. Okay. So meaning that we're gonna get all of them are positive. So we need to determine which one gonna be positive, which one gonna be negative. And then this is the side will be positive, right? So we call student. Okay, all student. And then this one only both sine cosine are negative, but only the tangent's positive. So we're gonna take our student take calculus. Okay, so calculus meaning that only the cosine will be positive, the other thing will be negative. But I feel like using this trick was so crazy. So all student take calculus, right? All student take calculus. But I don't like this. We can change that to like all stripper take cash. So it's actually a little better, but it's a little bit more offensive, but it generally makes sense. All stripper take cash. So all meaning that all of them are positive, right? All are positive, right? Positive for all. And then S, only the side, S represent the student, only the side positive, okay? Peg meaning the tangent, T for tag, the tangent, only tangent is positive. The calculus be cosine, only the cosine positive, okay? But I feel like it's harder by saying all students take calculus. I mean, not every student take calculus when they graduate. There are many of them didn't take calculus, but we say all stripper take cash, that makes more sense. Like all of them are positive. The S meaning the side will be positive. The tech gonna be the tangent positive, and then the cash will be the cosine or positive, right? Okay, so I'm sorry for that. So now we look at this trigonometry. So if the cosine is on quadrant number 4, right? So quadrant number 4, you think of it. So this is quadrant 4. So we look at the trig that we have, meaning that only cosine positive, right? The other thing will be negative, including sine, including tangent, the secant, all of those will be negative. Only cosines are positive. Okay, outer index will be negative. Okay. All right. So understand this trick. So we're not going to use the way I saw the problem because it's very confusing. Okay. So what kind of things that we should use in order to deal with this questions? So that's going to be a big deal. That's going to be a really big deal. So we're going to use some sine cosine rules, which is somehow easier to imagine on the trigonometry ratio. I would say it's going to be so much easier to do it like this. Okay, so I'm going to use the trigonometry ratio in order to deal with this question. It's almost impossible to follow the rule that we have over there. Okay, so the trigonometry rule is going to tell us that, well, I want to change the data. I want to change the data to t, so I don't want to use the data because it's a little hard for me to write. And then we also use t for the problem, so I would just stick to that. So this is the size of t. And then this is the cosine of t and tans of t. So we need to make sure that we understand the SOHCAHTOA. This is what we have for trigonometry rules in this case. Okay, SOHCAHTOA. So what does that mean by the SOHCAHTOA? Basically, we're going to utilize this rule to analyze the angle in this case, and then the side length of sine, cosine, and tangent. Okay, so we can think of it, the sine will be equal to what? Will be equal to the opposite over the hypotenuse. Opposite side length over the hypotenuse. So understanding this rule going to be very beneficial. Of opposite over hypotenuse. Right? And then the same thing for a chi, which is a cosine, would be adjacent over hypotenuse, so on and so forth. You can see that. And then the tangent is going to be the opposites over adjacent. So opposite going to be y over x. Okay, so so this is what it means. So I'm not going to write it down, but we need to understand this picture to solve the problem. So now we bring the problem to the other side of the trigonometry. Okay, so let me just rewrite them again. So let's cosine equal to 12 or 13, and then you're going to find the other trigonometry functions. So now we're going to bring here, so for the opposites over adjacent, so on and so forth, right? Sine, cosine. Okay, so we know the fact that for quadrant number 4, we don't have enough space, so we're going to move up to the slide. So we know the fact that only cosine positive. All right, so what does that mean by that? What does that mean by that? If the cosine is positive, meaning that the other thing will be negative, but you don't have to worry about that. So first, we're gonna draw a triangle, right? So so the angle that we call, usually I use this one. Just want to make sure that it's fair for a right triangle. Okay, we use a right triangle perspective to solve a problem. So this is what we call T. Okay. So now we know the fact that the cosine of T will be equal to adjacent over hypotenuse. Okay, so I think that you need to memorize this rule. Adjacent over hypotenuse. Okay. So what does that mean by the adjacent? So the adjacent will be the side length that is adjacent to the angle. So this is going to be adjacent. Okay. And then the hypotenuse, on the other hand, is will be the opposite side length of 90-degree angle. So this will be hypotenuse. Okay. So in other words, that we have the cosine will be equal to 12 or 13. Over 13 in this case, right? So this is what is given from the question. So we see that the cosine will be 12 or 13. So that will be adjacent is going to be 12, and then hypotenuse is going to be 13. Everybody sees that? Are we good? So we learn it that way so we can basically solve every single problem a lot easier. So let me to repeat that again so we can think of it. We can think of the sine will be of a right angle, of a right triangle, basically the opposites over hypotenuse, and cosine going to be adjacent over hypotenuse. The tangent is going to be the opposites over adjacent. Okay, is that good? Okay, so So basically what we need to do is that, well, I'm going to rewrite the cosine. If you forgot it, just put it on your notes. I think it's on a final exam, so you don't have to memorize any of this. Okay. All right, so we think of it, the cosine going to be the adjacent over hypotenuse. So the cosine going to be the adjacent side length over the longest side length, which is hypotenuse 13. So 12 and 13. So you put that down at 12 and 13. So we need to figure out the side length in this case. And then we can use the right triangle perspective to solve for the problem. So by the Pythagorean theorem, so we can also figure it out. This side length, because this is opposite, right? So this is the opposite side length. The opposite is going to be what? Plus square. So we're going to get a squared plus b squared equal to c squared because of the right triangle perspective. Okay, so now we can just literally take the a will be the opposite. So that'll be opposite square plus b squared 12 squared will be adjacent equal to 13 squared. Okay, so now we can solve for the opposites. So we know we basically got the opposite square plus, so 12 squared is 144 and then 13 squared 169, correct? And then we can subtract that. We can get the opposite square equal to, so we're going to minus both sides by 144. So we're going to take minus 144 both sides. Okay, so we're going to take 169 over 144 minus 144. So we get 25. And then we're going to take the square root. Opposite, we're going to be square root of that. So that'd be the square of 25. So this one will be equal to 5. Are we good? Are we good with this?
Yes.
Okay. So now using this perspective, because this one is so important, the one's so important. A lot of you might be asking, like, does that have something to do? Does that have anything to do with the question that we solve? Why the cosine is 12 or 13? And then how can we figure out the added side length? And then it's definitely not going to be appropriate on the picture that we found, but it doesn't matter. We're going to use the right triangle perspective to figure out the other trigonometry. Okay, so this is why it's hard. So, and then using the perspective of the right triangle, that we can have the sine, cosine, tangent, and then we can literally just plug that in. Yes, that's a good question. Would that be negative if the sine would be negative because only cosine positive according to the quadrant that we see right there, right? That's a good question, but yes, we definitely have to stick with that. On the final exam, it's so important. Now we're gonna figure out the sine of t based on the root that we have for the opposites over hypotenuse. So remember, the sine going to be opposite over hypotenuse, the cosine going to be adjacent over hypotenuse, and the tangent is going to be opposite over adjacent. So we call this one just so meaning that meaning opposites over hypotenuse, right? Opposites over hypotenuse, and then ka is literally adjacent over hypotenuse. And then tor. Basically, that one will be opposites over adjacent. Okay, so think of that way. So people usually memorize this rule a lot. And then a lot of you might ask me, like, how can we determine the sine of the sine and tangent and cosine? So now we're gonna use the trick for trigonometry. All students take calculus, basically the positive for all values, and then student means only side positive, the tangent is positive, the C means only cosine positive. Or we can use another term that I came up with, which is all stripper take cash. So this one is actually easier to memorize. So all meaning all of them, stripper mean side positive, take mean tangent positive, cash meaning cosine positive. So whatever the term that you can memorize it. So it's easier because remember the side is so important that we can understand what value for the index coming from, right? So on the full quadrant, the index for y should be negative. So like Justin just said earlier, so we can think of it, the size of t in this case gonna be the opposite over hypotenuse, right? Because so opposites over hypotenuse. Hypotenuse that we have would be the opposite side length would be 5, correct? Because this is what we have found, and then hypotenuse is going to be 13. Okay, so remember the triangle theorem is going to give you the side length, but it doesn't tell you directly about the sides, about the where the index coming from, right? So this is the index for sine here coming from the full quadrant. So meaning that this one should be negative, right? So the sine will be negative, only cosine positive, meaning that we have to change that to -5 or 13. I mean, the triangle doesn't give you the sign, but the quadrant is going to give you the sign. So quadrant number 4 is harder because we understand that the sign will be negative. On the other hand, that we can figure the tangent, that's going to be the opposite over adjacent, right? Opposite over polar, right? Polar. Opposite over adjacent, so we can figure out the index. So remember, only on quadrant number 4, only cosines are positive, right? So the tangent in this case, we take the opposite over adjacent, so it'll be 5 over 12. So that's supposed to be positive value, but because this is on the full quadrant, meaning that all the indexes will be negative except for cosine. So the index for tangent will also be negative. Are we good? The secant, so the secant, some of you might be like, what is the secant in this case? So I'm going to use a different marker. So that'll be the inverse of cosine, okay? So the inverse of cosine in this case, the secant would be positive as well, actually. So the secant also positive because that inverse. So the inverse of cosine would be the hypotenuse over adjacent. So that would be 13 over 12. So this one's positive. I mean, we actually don't count the secant in this case. And then the cotangent, on the other hand, will be the inverse of tan, right? So the inverse of tan, so the tan that we found was -5 over 12. So the cotangents will be, the inverse of that will be -12 over 5. As simple as that. And that's it. And that's pretty much the whole story that we care about. And then, so the index for y in this case, so the y will be 5 over 5 over 13. I'm sorry, -5 over 13 in this case. So the index right here, the y here will be -5 over 13, right? Correct? The index for y should be -5 over 13, just found. Okay. Any questions? Any concern? We should have more practice, correct? Yeah. If you ask me how it's gonna be hard, well, if you don't understand the rules, if you understand the rules, and then you should know which quadrant that it has, and then you should be fine. Okay. So this is not correct. So usually on the exams, this is basically belong to the first and the second quadrant. This might be hard. On the final exams, you will be given by a very specific quadrant. So I'm gonna change this one. Okay, I'm gonna change this one. This one is hard because the question is going to ask us to determine a quadrant. It doesn't necessarily tell you which quadrant was that. And then, so it might be very misleading information. On the final exam, it's clear. Okay, it's very clear that it's going to be on the first quadrant, the second quadrant, and third quadrant, and so on and so forth. Now, this is like 0 and pi. It basically bounded between the first and the second quadrant. However, the secant is less than 0. So remember, the first quadrant, both x, all of them are positive. So basically, the index will be on the second quadrant. So the angle t will be on the second quadrant, or quadrant 2. Okay. So now on the second quadrant, so we understand on the second quadrant, basically we know the fact that only sides are positive because stripper, correct? The first quadrant, everything gonna be positive, but on the second quadrant, only side positive, right? On the stripper positive, right? Student positive. The cosines, tangents are negative, and so on and so forth. So when we draw a right triangle, so you gotta be careful. Okay, so this is what we have for angle t. It doesn't matter which one we call. You can call this one angle t, but we need to determine the opposite, and then the adjacent, and then the hypotenuse appropriately, right? So if I call this one as the angle, so meaning that this side length will be the opposite side length, correct? Right? The angle that go across the side length will be called the opposite, and this one we call adjacent, and this one we call hypotenuse. So I usually use this angle as t instead of that one because I have to switch the position for the opposite and adjacent. So just follow this method, and then it should be good for this. Okay, so the hypotenuse always be on top of this because this is 90 degree. The hypotenuse always be the side length that is opposite to the 90-degree angle. But anyhow, so given by the secant, so the secant is what? The secant is not given from the traits, right? We don't have the trait right there, but we understand that the secant will be the inverse of cosine. Okay, we memorize it. The secant will be the inverse of cosine of t. So now we think of it. So what is the cosine? The cosine will be what? The cosine going to be adjacent over what people? Adjacent over hypotenuse, correct? Right? Yeah. If you don't remember the rules, it's gonna put like so car toward actually. So the cosine going to be adjacent over hypotenuse. So the inverse of that, so inverse meaning you're going to flip it. You're going to flip. It's not finding the inverse of that. The inverse of the flip. You're going to flip the term. So in this case, we can think of the secant as so we have to flip that term. So that would be the hypotenuse over adjacent. You're gonna flip that part. It's correct. So remember, this question is going to be because this question is going to be in the final exam. So we really want to make sure that people understand the rule, the SOHCAHTOA rule. So when you do the math problems, so you don't really get shocked. Like, hey, what is the secant? What is the sine? What is cosine? What is the tangent? So on and so forth. So now we can think of it. So the question gives like a secant equal to negative, but you don't care about the negative in terms of the side length of a right angle, of a right triangle. So we just literally just put down 17/8. Okay, we ignore the side first. We're gonna take care of the side whenever it comes to the final answer. We try to nail down to the final answers at the end, but we need to understand like how we're gonna figure out the other side length of the triangle. Okay, so the hypotenuse in this case will be 17 according to the question, right? This is the ratio. Adjacent is going to be 8, right? And then I need to figure out the opposite. So according to Pythagoras theorem, that we have a squared plus b squared equal to c squared, right? So it's right triangle, so we can understand that the opposite square, so we don't have the opposite in this case, plus b squared. So b squared is given, b squared going to be adjacent, right? This is a this is b, and this is c. Okay. All right, and then the b square going to be adjacent square, going to be 8 squared equal to 17 squared. So, and then you can figure it out. So a squared going to be 64. Uh, 7289. Just want to make sure that it's correct. Usually I don't have any trouble with some square, but I just want to make sure it's correctly. So we can subtract 65 both sides. So we can look for the opposite square equal to 289 minus 65. Oh, it's six. Oh, I'm sorry, 64. I'm sorry with this. Yeah, I'm so sorry. It's 64. Yeah, I haven't have breakfast yet. I just literally cooked my son, and then I just came back to teach. So I'm so hungry, which is something you have especially for. Yeah, and then so we're gonna subtract that 289 minus 289 minus 64 will be 225. And then we can look for the opposite side length in this case. So that would be it's radical 225. It's 15. Okay, so the opposite side length is equal to 15. So we can literally figure out the added trigonometry. So the second quadrant, so the angle should be second quadrant. The second quadrant meaning that only side positive, right? Only side positive. The other thing will be negative. So we can figure out the cosine in this case. So the sides of t. So all these sides positive. Remember, side will be positive is on the second quadrant. So when you put it down on your note, you're not going to use this trick right here. So we might use a trick that I showed you earlier, which is the trick that we have here, right? Only side positive in the second quadrant. The information that we have here is very misleading because the angle between 0 to 180 degree on the second quadrant, but usually is actually on the second quadrant because the secant is negative. So if that is on the first quadrant, the secant will be positive because all of them are positive. So now we can have the sine equal to, so by SOHCAHTOA, that would be the opposite over hypotenuse, right? Okay, so opposite over hypotenuse. So we basically know that the opposite side length, which is 5, was 15 over hypotenuse was 17. And this one is positive, right? This one's positive, so it's good. And then we can also figure out the cosine. The cosine of t will be the cosine going to be the adjacent over hypotenuse. But remember that the adjacents will be 8. Hypotenuse going to be 17, but now we got to be careful because this cosine is actually negative, right? On the second quadrant, obviously. The cosine can be negative, can be positive on the second quadrant. The second quadrant, the x is going to be negative. This x is going to be the cosine. It's negative, so the second quadrant will be negative for cosine. So this one should be negative 8 over 17. Okay, so this one will be negative, right? And then we can figure out the tangent. So the tangent of t, in this case, I feel like tangent and secant, that should be good enough. The cotangent is just the flip of the tangent. And then that's pretty much it, okay? No, the cosine will just flip. So we can actually figure out a cosine by the secant. So we just flip the secant, you get negative 8 over 17. You don't necessarily have to use the roots because if you know the secant is the inverse of the cosine, then we can just figure it out easier. And then the tangents, that would be the opposites over adjacent. So the opposites over adjacent, so the opposite side length will 15, the adjacent will be 8. So that 15 over 8. So remember the tangent will also be negative because it's on the second quadrant. Oh my goodness, so it's really hard to draw. Okay. So this one less than 0, so you have to put a negative sign in front. The cotangent just negative 8 over 15, and so on and so forth. Are we good? Are we good with this? You need one more example? I feel like every example just worked like this. First, we need to know whether or not it's on the first quadrant, second quadrant, third quadrant, the fourth quadrant. The second thing that we need to do is just draw a right triangle, and then you're gonna tell me which one you're gonna be opposite side length, adjacent, hypotenuse. Yeah, so one more, and then that's basically the thing. So this example, I'm not gonna give you the whole numbers. I'm gonna come up with my own values here. So if the cosine of t equal to negative 1 over 4. Okay, so I'm not going to give you like the whole values here. And t is in the third quadrant. Okay, third quadrant, the quadrant 3. So find the other trigonometry. Specifically, I'm going to ask you to find the size of t and the tangent of t. Okay, yeah, specifically. So so third quadrant, meaning that all of this will be negative, right? Except for tangent. The student take calculus, so take the tangents, only tangent positive. So you can figure it that way, only tangent positive. Positive, right? And then I'm gonna draw the trigonometries here, and then so we're gonna look for the t's here. And this is the angle t, and then this is gonna be the opposite, and then this is gonna be the adjacent. and it's going to be the hypotenuse. So we don't necessarily have to remember the orders. So we know the fact that the cosine is. Remember that when we analyze the trigonometry on a triangle, make sure that all the side length, all the cosines are positive, right? So even if the question gives you -1/4, so we have to rewrite that as +1/4. So by the SOHCAHTOA, that we understand that the SOHCAHTOA, it's literally the cosine going to be the adjacent over hypotenuse, right? Hypotenuse is basically going to be the longest side length that we can see in the picture. So hypotenuse is going to be 4 because hypotenuse is 4 on the other side, right? And then the adjacent is 1, right? So 1/4. Adjacent is 1, hypotenuse is 4. Adjacent is 1 here. Okay. Right. So now I need to figure out the opposite, right? Now I do that one more time. I should give you the sign because every single problem just give you cosine and you don't have to figure out the opposite. But I should give you the sign so you can figure it out a lot easier. So the a squared plus b squared equals to c squared. So we can have like the a squared will be opposite square. So I don't care whatever you call the a. So the a should be either one of this, right? The c should be the longest side length, which is hypotenuse. So the opposite square O plus b square going to be 1 square equal to c square equal to 4 square. I should give you the sign so that you can figure it out. So the opposite is 1, you're gonna get adjacent, you have to figure out adjacent, same thing, but generally the same thing. Anyhow, so we're gonna have the opposite square plus 1 equal to 16. So we can figure out the opposite side length in this case will be 16 minus 1 equal to 15. So meaning that we're going to take the square for this, the opposite side length is going to be the square root of 15. So given by the opposite side length equal to 15, I'm sorry, radical 15, so this one going to be the radical 15. I can't figure out the sine and the tangents relatively quickly, correct? So because we have all the roots. So we can also have the size of t will be the side going to be the SOH, right? The SOHCAHTOA, SOH. So that would be opposites over adjacent. Opposites over adjacent. So the opposite side length that we have will be what? The opposite side length is radical 15. Adjacent hypotenuse, adjacent is no. Side is the so I think I make a mistake. It should be over hypotenuse. I'm sorry. That yeah, I'm so sorry. It's having like a haven't anything yet, so I wrote it wrong. So I apologize. So the so is apparently that we just wrote it here, right? So was opposite over hypotenuse SOHCAHTOA. Yeah, I don't know why I just like write them down with the SOHCAHTOA. I'm sorry about that. Okay, that should be over. Yeah, when it rolled because the sine and the cosine should be less than 1. So radical 15 over 1, that's make no sense. So that should be over hypotenuse. Hypotenuse is 4. It should be over 4. I know it's over 4, but I don't know why I just wrote so as SOA. It should be SOH. So that would be radical 15 over 4. So that's will be the final answers for the sine. But remember, because this is the third quadrant, so the sine will be negative. So we have to change that to a negative. Yeah, it's the tangent. That's correct. So the opposite over adjacent is going to be the tangent. So remember, this one going to be less than 0. Apparently, because on the third quadrant, only tangent is positive, right? Remember, on the third quadrant, when the tangent is positive, you forgot the rule. We're going to remember by reading all of this, all of the things here. Where's the rule that we have? No, I don't see it. Oh, right here. Yeah, all the root trick for trigonometry. So positive for all of them. The student. The tick would be the tangent positive, and then the other things will be negative. So come back to the question that we can have here. So on the side is positive, the other thing will be negative, right? So the cosine is 1 over 4 is actually negative 1 over 4. But since we put it down in terms of the trigonometry in the right triangle, so we have to make that positive. But in other words, the cosine is negative, right? So just don't want to make sure. I just want to make sure that it's this one negative 1 over 4. In terms of side length, that doesn't make sense. But in terms of the unit circle, this is where we need to figure out the indexes. So the size of t will be negative 15 over 4. And then we can also figure out the tangent of t. So as Justin just said, as the tangent of t will be toward will be opposite over adjacent. So that basically give us the final answers. Remember, the tangent will be positive. This is on the third quadrant, so the opposite over hypotenuse. And then that's going to give us opposites over adjacent. I apologize, over adjacent. For the tangent. So that basically going to give us the opposite will be radical 15 over 1, which is radical 15. Are we good? Are we good with this? Any question? I can't really draw those correctly. My mouse sucks, and then my handwriting sucks, so it might be even bad for you guys when you read my lecture, correct? No, I apologize for this. Could it be a negative? No, the tangent will be positive. Remember, on the third quadrant, only tangent positive. So we're gonna use the trick that we have over here, right? On the third quadrant, the tangent will be positive. You can see that, right? Tangent is positive right there. Tick. All stripper take cash. The tick represent tangent, right? The t represent the tangent is positive. So this one's positive. All right, so much for that. Any question? Any concern? Okay, so we're going to ignore all of this. This is like we're using trigonometry, like sine, which is called so, right? Opposite over hypotenuse, cosine, adjacent hypotenuse, tangent opposite over adjacent to figure it out. All of that side length. But yeah, this is so important. If you are looking for the architecture major, trigonometry is very beneficial, right? If you have to measure a certain degree, a certain radian, and then you can determine the side length of a certain object relatively quickly, But again, that we're not gonna spend time. If you want to measure like how high the tree, if you can measure the angle of that, which is relatively okay from that person standing from the base of the trees. But that's cool to estimate the height of a certain object. So it makes sense. But since it's not going to be in a final exam, so I'm going to skip all of this. Okay, are we good? Any question?
No.
Okay, so next class that we're gonna have some very crazy thing about periodic functions. We're gonna learn this tomorrow. You like these questions? You like, how much do you like these questions? You love this question, something like this? But you need to understand the rule, correct? Yeah, so we're gonna have a quiz on it tomorrow. I mean, the only thing that you have to be worried will be the quadrant. The quadrant determines the sign of the sine, cosines, tangents, and all trigonometry. The second thing that we need to understand would be the right triangle perspective, uh, with respect to the SOHCAHTOA. So that's so important to draw out the right triangle and then determine the opposite, the adjacent, hypotenuse. Don't be like me, make sure they have breadth first. You're not gonna write sine equal to something like this. Yes, Blessing, you have questions?
Yeah, is today's section going to be added to Blackboard?
Yes, it will be added under lecture notes and lecture video. So it's not available yet because I haven't really added some material on it, but you should be able to just view it after class. So I have to convert the whole lectures on YouTube. And then you can watch over again if you have any questions, any concern. The only thing that bothered me will be some of the angle on it. So a lot of you might not be able to figure that out. So let's say, what is the size of 225? So it might be the thing that we have trouble with, right? So size of 225 degree, size of 225. So you can see that you should get like past a negative 0.707, negative 0.707 in a calculator. Yeah, we're gonna have classwork, and then I don't know why the campus just give us a whole bunch of trouble on Zoom. Now we have to do the lecture on Zoom, and then we have to submit the classwork on Zoom as well. I'm sorry, on a Blackboard as well. So I would rather you guys just do it on a paper, just send it to me. I'm not trying to give you a lot of trouble, but I do have a hard copy for it. Okay, so if you think that you cannot do it now, it is understandable. Okay, it is understandable. But I really want to make sure. So again, that for those of you who study like angle, so why I'm not using data, because it's hard for me to draw. It doesn't mean that the data. So I check it on Google. The data should be used as an angle, but UT. Anyhow, because we do not have the lectures on campus, so I cannot give you the hard copy for it. So which means that it requires you guys to do the classwork. You have to do the classwork on Blackboard. Okay, so you need to evaluate what is the size of 5 pi over 4, and so on and so forth. Okay, so we're gonna ignore question number 5. Okay, just ignore it. We're gonna go over this little topic hopefully tomorrow if we have times. I mean, we have to go over it, but we can ignore question number 5, 4, and 5, right? Ignore it because we do not have time to figure that out. But we're definitely gonna figure it out tomorrow. Okay, so I'm so tired for us today. Okay, so we definitely gonna go over it tomorrow. Okay, so we can skip 4 and 5, but we should be able to do 1, 2, 3. Okay, 1, 2, and 3. All right, so let me just save it. Okay. Yeah, we do everything except 4 and 5. I think 4 and 5 would be on the final exam as well, but I feel like you guys are really tired, including myself. It's not easy to teach trigonometry in such a way that you can understand it perfectly. At least that you're not gonna get scared of what is the sine, what is the cosine, and the unit circle is just x and y value. But on a right triangle, it will be opposites over hypotenuse, so that's going to be for sine, cosine going to be adjacent over hypotenuse. Yeah. So now I'm going to give you the assignments. Classwork 6, 7. All right, I couldn't find it here. What's happening? Yeah, it's due at the end of the date, but I want to make sure that people, yeah, right here, they will get the file. It's only 5 points. Then the submission you want to, let's do today. Yeah, we're gonna have a quiz tomorrow. One thing had to be done on this assessment as well. Yeah. Yeah, so yeah, that's the big deal. Some of you might be like, how can I submit work on Blackboard, right? So how many people do not know how to submit it? So first, we can also download the Adobe scanner, Adobe scanner. So this one is really good on your phone, right? So we're gonna do it on a piece of paper, right? Do the classwork on a piece of paper. And then we're gonna take pictures, and then we're gonna convert into the PDF file. Or we can use the cam scanner. I think it's much easier. Some of you prefer the iPhone scanner, but iPhone scanner, to be honest, it sucks. It's really hard for me to read. So yeah, PDF scanner, the cam scanner is this free? I'm not sure if that's free. I would prefer Adobe scanner because it's much better than cam. I'm not sure, but it's depending on how you look at it. But they both have 100 million plus downloads, so that should be great to have it. So you're gonna do it on a piece of paper, and then you're gonna scan it, and then you're gonna upload it on Blackboard. Okay, so how can I find the notes, the lectures? So it's very simple. You go to Blackboard, click announcement, click information, you don't see them. You have my information here, but you click the course assessment, so you should have classwork number 7, and then you just click the file here and do the questions on a piece of paper, convert them into PDF file, and then just submit it, right? How can I submit it? It's basically not quite easy. So click on home classwork 7, right? And then on your phone, you can do it on your phone. You can get on Blackboard on your phones, or you can email yourself and then drag it out on the computer. And then you're gonna browse my local files, and then you're gonna have the file submitted. Okay, so let's say I want to submit this file. I just click open, and then you're gonna attach the files, and then you're gonna hit the submit key. Okay. Are we good? You have to hit this one. If you don't hit this, well, it will not get through it to the system. All right. So, any questions? All right. So, since this is the class online class, so I'm not gonna I'm not gonna watch you like do the classwork, but it should be available. You guys gonna submit it by end of date. Yes, you can also print it out if you want to. It's great, but I prefer online so I can see the mistakes that you make, so that I can help you progress. You know, uh, the lectures. I want to see like what else that you need to get through it, the concept. Okay, so we're definitely gonna go over the other questions for N5 tomorrow, but I know it's tired and then people just want to leave. Usually that we have to stay until 11:30, but since this is online course, online class for today, um, I will let you guys out early. Okay, so I feel like that's pretty much it. And the second exam grade is on Blackboard. You can check and let me know if you have any questions. So before we leave, I think we need to take attendance. Okay, so Ashley's here, Raris is here, is not Christians is here, Joseph is here, Yahiro is not here, I think. Hector is not here. Juan is here, Chris is here, Justin is here. Thank you so much for your participation. I take note of it. For each person who came on the board, I take note. So, so for those of you who take who get on the board, I knew it. Freddie is here. Yeah, Leslie is here, and he's here. Blessing is here. Any other questions? Yes, I saw some hand raised. Any questions so far?
Professor, you said questions 4 and 5 on the classwork to ignore,
Yeah.
right?
Yeah, we're gonna do it tomorrow together, but we ignore it. All right. I believe that's pretty much it. I will see you guys tomorrow on Zoom, correct? Because the department chair says that the borrowing system, the system is gonna work by tomorrow morning. But again, she want to make sure that all of us is not go on campus. So we're gonna come back to the campus class on Thursday and Fridays. Have to be on campus because we need to get it done through a very complicated material. So anyhow, so that's pretty much what we have for classwork 7. And you guys have a wonderful day. Take care. I'll see you guys here. I see you guys on Zoom here. One more lecture tomorrow. Bye-bye.
Professor, one more question.
Yeah.
Tomorrow's
All right, bye,
quiz is
Professor.
tomorrow's quiz is gonna be 2 questions as well, or
One question. So only be these
Okay.
questions. I mean, the
Okay.
same title question, but not going to be the same. Because we need to know, I just changed the ratio for that maybe. Okay.
okay,
All right. So take care.
take care.